get started, I would like to introduce Kaizen's own Scott Cain.
Thank you, Chelsea. And good morning, everyone. And thanks for spending a few minutes with us on this beautiful Thursday morning. We're going to take a few minutes today and we're going to talk about cleaning no cleans. And why would you or why would you not? And I know it seems counterintuitive to talk about cleaning no cleans. It's right there in the name that says no clean, but it's a little more in depth than that. And so we're going to spend a few minutes kind of walking through what that means and if you are going to clean, what that looks like. So let's spend a few minutes and explore. So first off, what do all of these things have in common? Got Chinese checkers and lightning bugs or fireflies, depending on where you're from. Some peanuts and a koala bear. Well, stick around to the end and we'll tell you why all of these things are misnomers. You know, a misnomer is a wrong or inaccurate name or designation, or maybe the wrong way to use that name or designation. And that's really what no clean is in our industry. Kind of the more correct term for these would be low residue. And that's pointed out, one of the leading flux manufacturing companies states, no clean processes leave residues that remain for the life of the product. So it's acknowledged that they're there. What are those residues and what do we need to do with those residues that are left on in a no clean, now we're going to call low residue application? So let's back up a little bit, just do a little bit of history on kind of how circuit boards have moved through, when no cleans came in, and so on and so forth. You know, if we think back to the boards we've seen from the 1970s and 80s, right, they were really big and there were big components on it, lots of space, and a lot of that was done using vapor degreasing and other cleaning. And then saponifiers came in the 1990s. Well, that's where no clean came in the 1990s, because Montreal Protocol said that we can't use some of these vapor degreasing chemistries anymore. And so the flux companies came up with no clean, thinking that would alleviate the need for cleaning, and that took off in the marketplace. So what we see now is the marketplace has, you know, three different types of fluxes. Really, the RMAs and the water solubles are really low market share, but if you are using those, there are other tech-to-tech presentations about those if you guys would like to go back and learn about those. But really, no cleans are 85% of the market share, and the majority of them are being cleaned. You know, the IPC numbers are a little bit varying. It's somewhere between 50 and 80% of them. And obviously, if they weren't being cleaned, then I would probably be out of a job and Kaizen would be hurting as a company. The main thing with the no cleans is the polymer encapsulates the residues. So whatever residue they're trying to get off, it's going to be encapsulated and kind of covered. So that's going to be kind of key as we go forward. So one of the things to think about when we talk about 85% of the marketplace, no cleans are used across the board. Everything from your Game Boy to your iPad to your laptop to missile defense systems and satellite systems and medical. But really what we want to look at is, what are the differences between those IPC classes? You know, what's the cost of failure on these? So class 1 or 2, right? We talked about class 3. That's going to be your super high reliability, big pain if there's a failure. Those are obviously going to be cleaned. What about class 1 and class 2? You know, we want to think about things like, what's the environment? Is this going underground where it's going to be hard to replace, or is there going to be a lot of humidity and there's going to be water? Is it going to be hard to get to? Those type of things. What are the demands? You know, what's the life cycle on the product expected to be? What is the environment that it's going to be in? How long is it expected to last, etc.? And then, are there bottom termination components? Are those small components where we're going to have to get in? Are we going to be able to get in there? Or is some of that residue going to stay there? And finally, what's the cost of failure? You know, if the Game Boy dies, yeah, it's going to be a long trip and Billy's going to be screaming a little bit, but that's a whole lot different than if a braking system on your car fails, and what's the replacement and what's the total cost of what's at risk. So keep in mind, corrosion accounts for more than 50% of electrical system failures. And that's what we're trying to figure out is, do we need to clean those class 1, class 2 no cleans? So there are some concerns with nose cleans. And really, some of those come down to, are the flux residues really neutralized? There's a lot of different things that are part of that. Is it completely gassed out under these BTCs, these bottom terminated components? What happens if that encapsulation of the flux is disturbed and that flux is opened back up into the environment? Also, the rework, and is there solder plate flux under the large thermal mass components? And then there's other contaminants. We think of flux, but we also need to think of all the contamination that comes from the bareboard manufacturing, the salts, the cutting oils, the finger oils that come in. And if people aren't wearing their gloves, whatever they had for lunch or a breakfast sandwich or Cheetos or whatever, all these things can create contamination on boards that are cleaned off, including using with the no clean fluxes. So there is a risk with no clean flux. Many believe it's kind of, we'll use it everywhere, it's no problem, it's going to be safe and reliable. And that's not completely true. If it's improperly processed, it can lead to electrochemical migration and dendritic growth. And that's what we're here trying to avoid. The dendritic growth is going to create the intermittent shorts, the current leakage, and can create catastrophic failures. And so we need to make sure that we have everything in line to not have the dendritic growth. So what's the proper use of the no clean flux and the end use environment that we talked about? So why to clean the no cleans? First off, the reliability of the boards, right? It's going to get everything cleaned off that we've talked about. You're going to have a cleaner board. It's more reliable because there's less chance of the dendritic growth. There's going to be a consistency in your in-circuit testing. Some of the no cleans create kind of a putty matter, if you will, after they're processed, and sometimes the in-circuit testing doesn't really like that, and there's problems with that. No cleans, we're seeing the boards get more and more small, right? You guys see it. You think about what it would take to have the computing power of your cell phone 10 years ago compared to the boards we're seeing now, and how small everything is getting and how much taller things are getting, but everything's getting closer to the board and so much in there. Getting those no clean, those encapsulated residues out of there is going to create a more reliable board. The quality of your conformal coat. If you're putting a bumper sticker on your car, you always wash it down before you place the bumper sticker down. It's a really simple concept of what's going on with conformal coat. If we don't have that clean surface for the conformal coat, it's got less of a chance of sticking well and lasting through the life of the product. And finally, a superior cosmetic appearance. Sometimes cosmetic appearance doesn't matter, but other times when you're talking about video boards or something that the end consumer is going to have interface with, having those shiny solder joints actually can change the perception of the quality of the product. So how to clean the no cleans? One of the big things is to follow the manufacturer's instructions. Each individual no clean flux provides a reflow profile, and we want to make sure that that is followed really closely, because we don't want to have anything baked on, or we have the temperature too high or an exposure time too long. And then be aware of the combination of the machine, the chemistry, the process parameters, and the cleanliness results that you're getting. And once you've got that dialed in, stay with it. So kind of in summary, not everyone needs to clean their no cleans. That's influenced by these things like the geometry, the functional demands, and then what that end use environment is. And one of the things that we see that sometimes causes problems is people will spend all this time dialing everything in, from their reflow to their cleaning process for the qualification portion. And then they'll kind of let it stray a little bit once it gets to production. And that's where you can have more problems cleaning your no cleans if you're not staying within the standards that you set during the qualification. And if you do need to clean, understand the influencing factors. That's going to be your time, your temperature, your speed, if you're doing an inline, or how long it's going to be in the wash cycle, rinses, your water quality, all these type things that we can help you out with. So just kind of don't forget, like, we're here to help. We're pretty experienced in all angles of the cleaning process. Especially during these times. People are being pulled in a lot of different ways. Let us be an extension of your engineering department to help with these cleaning issues. We can run trials, we can provide our experience to make sure your process is on point. And obviously, we love talking about this stuff. Here every Thursday talking about some cleaning. So this is what we love to do. So now the reason you all stuck around, you want to know what these misnomers are. Chinese checkers were actually created in Germany, and it's not really checkers. Peanuts are not actually a nut, they're a bean. Those cute little koala bears are actually koala marsupials. My personal favorite is the fireflies or not flies. They should be either called fire beetles or fire lightning bug beetles. So thank you guys for spending a few minutes with us this morning. Just want to let you know, in 2 weeks, Charlie Pateras, one of our outstanding engineers, will be doing a presentation on electronics cleaning process control. We'd love to have you guys stop by again in 2 weeks and learn more from Charlie.
Thank you, Scott. If you'd like to discuss this topic further, please contact your local Kaizen representative or send an email to tech@kaizen.com, and we will have one of our cleaning experts schedule a follow-up with you as soon as possible. Again, we thank you all for joining us today, and we hope to see you again soon. Stay safe, stay healthy, and have a great day.